Hello everyone. We are very pleased today to have a special guest. I can see we have quite a bit of audience. And today we have with us Evagoras Xydas, an old friend and an excellent entrepreneur and academic part-time. So the talk today is about innovating through haptics, the IREROBOT journey. I will talk a bit about Evagoras, initially give a bit of background and then a summary of his talk. And so Evagoras is the CEO and founder of IREROBOT Limited, the Cypriot company, a Cypriot startup company. And it's leading the R&D startup specializing in haptics. Haptics, every time we have the touch. And so he holds his PhD in mechanical engineering from the University of Cyprus and master's in assistive technology from the King's College London. Where he studied in full scholarship. He's also an assistant professor in Frederick University and teaching there. Under his leadership, the IREROBOT company has secured significant funding and investments, earning the Deloitte Fast 50 Impact Award and ranking third in the impact across the Middle East and Cyprus. A haptics expert and innovative leader, he has spearheaded groundbreaking projects like the Asset and H-Glove, and advancing the sensory substitution of immersive technology. So today's talk is going to be about exploring the vision of technological advancements of IREROBOT and the leading of R&D companies specialized in haptics and sensory augmentation. It's augmenting our senses. So from the Asset, which is advanced, is it auditory communication enhancement through touch. So auditory communication enhancement through touch is a wearable device that converts sound into vibrations for deaf people. So the H-Glove, it's a haptic glove enhancing the immersion of extended reality. IREROBOT is transforming human-machine interaction. The talk is also highlighting the entrepreneurial journey of its founder, and it's covering milestones such as securing funding, overcoming challenges, and scaling innovation from research to commercialization. It offers significant insight into deep tech entrepreneurship, impact-driven innovation, and the future of haptics. Off you go.
Yeah, let's speak about our company, IREROBOT. Not anymore my company. It exists for some years, and this means that a lot of people have already contributed almost as equally as I did. Our and we work with technologies for touch. So at IREROBOT, we try to connect people with both the digital and physical world through touch. We try to create deeper connections and provide access where needed using haptic devices. Haptic devices are devices that use touch to convey information. So Christopher already said some stuff about me. What I feel important and significant to share about me. I mean, a lot of people have PhDs, doesn't mean nothing. And what I feel that important that I'm doing in my life is that I created a startup which solves a real world problem with innovative solutions. This has a direct impact on the society. It's very fulfilling, and it's something that I consider the highlight of my professional life. I'm supported by an incredible team of people that have helped us reach this far, and nobody can succeed alone. You always need to find the right people. Okay, so why touch? When we meet, we shake hands, right? We don't simply stare at each other. Even societies which don't shake hands, they don't shake hands because touch brings you very close. So they do it for the same reason. But also when we shake hands, this is a sensory blast on our palm alone, we have 15,000 biosensors of 4 types that convey a lot of different types of information. And by a single handshake, people close deals of millions, or they can even mistrust the other person or trust the other person just with a shake. We get all this information on our palm. Then why are haptic interfaces? Why is touch needed in solutions? Let me ask you something. You go try to buy something on Amazon, right? You look at it. You can open it in 3D, turn it around, look at it, and you touch it. No, you can't, right? So there are reasons why tactile information is not available so much, and we're going to talk about it hopefully. We have created 2 products that are related to touch, asset, and edge cloud. Asset converts information, sound information into touch, and this is for deaf people. It provides immersion to deaf people into the acoustic world. Edge Glove connects people to virtual objects in a virtual reality environment through touch. This has implications in training, gaming, so on. So a little bit about asset. I'm not sure if you are aware, but there's more than 500 million people in the world that live with disabling hearing loss. And the traditional approaches that these people can use are not so effective. Lip reading is very hard to do. Even the most advanced lip readers manage to get only 30% of the words that are being said. Is it effective or not? What do you think? Which of you speaks the sign language? So you got your answer. And of course, there are modern transformative technologies such as cochlear implants and hearing aids. But just to give you an example, in Europe, the European Union, there are 7 million people with deafness, and only 150,000 of them have cochlear implants. So the rest of them are completely isolated from the acoustic veil of the world. Okay, so when I was doing my PhD, I had this idea to make people listen through touch. I told this to some people, some colleagues, some collaborators, high-level collaborators, professors. They all said, this is impossible. Okay. So at some point, I started doing my own research in this. I realized there was already some research, but not a lot before I started it. And what we did in this research is that we got some students. I was an assistant professor in Kazakhstan back then. I was there for 2 years. So we got some students and we delivered to them tones to the headphones and on their finger of equal frequency. They got some tones, only the sound, and some tones were given in a combination, touch plus sound. And we found out that at some specific frequencies, from 200 to around 400 hertz, people could hear at lower volume when touch was incorporated as well. Okay. So I studied this a bit more. I started learning about touch. And, on our hand, we have 4 different types of sensors: Merkel, Meissner, Pacini, and Ruffini. We have 15,000 of them. A very important such biosensor is the Pacini. And look, the Pacini corpuscle, which is the sensor that we use to feel vibration, to feel texture, which is also vibration more or less, is most sensitive at this range of frequencies we had identified as kind of creating this phenomenon, the audio-tactile integration, where touch enhances hearing. We did further research with more aggressive protocol, more aggressive isolation from sounds, and so on. And we made this definite that indeed, when touch was delivered together with sound at these frequencies, people could hear at lower volumes. Okay. And we published this in a Q1 medical journal. Also, one of the last significant research studies I did. Then I was absorbed by entrepreneurship and I didn't do so much research anymore. I did, but without publishing. Let's call it like this. Okay. Oh, sorry. And then we started trying to develop something that uses these ideas of being able to get information from touch. Right? And we realized that you cannot simply convey acoustic information. Because when we hear, we can hear to frequencies up to around 24,000 hertz. But when we feel vibrations, we can only feel vibrations up to around 500 hertz. And most sounds are up to 3,000 hertz. But even so, if you compress that information of 20 to 3,000 hertz into 20 to 500 hertz, you lose a lot of information. Because also a thing called just noticeable differences. So the resolution of feeling and so on. So something else we understood was that not all, if somebody is speaking to you and his voice is converted into touch, it's not a necessity that you will kind of receive what you feel on your hands as something relevant to what you are listening. This is called perceptual integration. Okay. So we realized that we needed to achieve perceptual integration. If the person is listening just a little bit, and you want to enhance that using information on his part, then you have to make sure that you have perceptual integration, that he feels that what's vibrating on his hand is relating to the little bit that he can hear or see if he's doing lip reading. Okay. So how did we establish that? These are the acoustic informations, acoustic frequencies of sound. So take this frequency, for example. It converts into tactile frequencies, which is from 0 to 400 hertz. Okay, it's 0 to 500 hertz, but if you play vibrations over 400 hertz, it's very audible. You can hear it a lot, and it's not convenient for a tactile display. So take this frequency, it is converted to frequencies on the tactile range, right? This is more widespread. It allows to deliver more information. And these frequencies fall within the range of the Cassinian corpus of sensitivity. So these frequencies excite audio-tactile integration in the phenomenon in which we basically hear using our hands, and the other frequencies deliver information. So with this, we achieve delivering a lot of information and also achieving perceptual integration. And also, when we hear, our cochlea maps frequencies into different locations. If we hear the phoneme A, this has 3 primary frequencies. Okay. When these frequencies reach the cochlea, they will be mapped to 3 different locations of the cochlea and follow different paths to the auditory cortex. So we'll have to do the same with touch. And what I thought back then was to use resonance, same thing as in the cochlea. This is a biomimetic solution. What we create are surfaces with different resonant frequencies at different locations. So if I deliver here this frequency, 408 Hz, I get this vibration. If I deliver 166 Hz, I get a different vibration. So in this way, we achieve spatial mapping in the same way that is done in the cochlea. In this way, we manage to give each sound and each voice its own unique character and style as it happens with hearing as well. Okay. This is a sample conversion of hearing frequency. So beyond that, we have to create our algorithm, which reads the sounds, that's FFT, which you may have studied, converts them, implements that curve, and so on. We have to create our own electronic solution, which is proprietary, and achieves low latency. Even the slightest latency between moving lips and what you feel is detectable by humans. And then it's like these sort of movies that which have a different language than the spoken one, and didn't match the lips. It doesn't make sense. So we achieved undetectable latency with this PCB, which took us 3 years to create, and a lot of trial and error. Even the first one we got, which is this one, was too big. It was crashing because it's based on a computer. So this is a new one. We finished this, and we are actually launching the device now in April, in a kiosk. And this, besides this person who is a researcher, are our, with their permission, are our dev beta testers. Everything was done in a user-driven design fashion. Beta testers were coming, testing, giving us feedback. In the first session, the feedback was terrible. You have to take it, swallow it, use it, accept it, put your ego down, and improve the device. In the later sessions, they loved the device. They said they would buy it. Okay. Now we are going to launch and see how it goes. Maybe the market will tell us something else, right? And we'll have to check it. So we also managed to create 2 international patents, one for our algorithm and one with that idea that mimics cochlea. Okay. Also, the electronic circuit is a haptic circuit basically, and it's proprietary. It's licensed to us for life. And new patents are coming out as well. So this is a video we made. And I made. So in reality, this video was made before and we used it to motivate ourselves to achieve stuff. Okay. We also added one more mode, which is music. And this was added by the deaf person because they said when they go in a music club, they go and stand next to the woofer and they feel the vibration on the floor. So we added a mode which picks up the rhythm and beat of the song and delivers its vibration on the floor.
Με το mouse ή με το screen.
Okay, so now about our next product, which is H-Glove. This is a haptic glove. Okay, a haptic glove connects people to virtual objects with touch. This is very important. I think you would like it if you try to grab your coffee, for example, and your hand goes through the cup. Would you like that? No, I think it's not natural. Then why are haptic gloves everywhere in all virtual reality? Well, the need was there since the first headset came out, since the first virtual reality headset came out. And the first haptic gloves made it to the market in 2007. They were wonderful gloves. But back then, because there was a strong need for virtual environments to be and feel natural. Okay. So back then, wireless connectivity was too slow, and the headset were not advanced enough to manage to adopt this technology. So it disappeared. But now wireless connectivity is fast enough. Headset technologies are and solutions are blooming. Applications are increasing month by month. And wireless connectivity is fast enough, it's cheap to design, manufacture electronics of low latency, and the time is just now, just right. So this is what we do at IREROBOT. We try to make this, to deal with this problem where extended reality solutions are not natural. We try to make them natural. This has implications in training, gaming, and many other applications, even remote assistance, and so on. So just a little note, what's extended reality? Yes, extended reality. What's extended reality? Exactly. It's in general. It includes mixed reality, augmented reality, and virtual reality. In the virtual reality, the world is virtual and has nothing to do with the real world. You are in a new world, which is digital. Okay. In augmented reality, you get a lot of information about the world, but you don't really interact with the world in the augmented reality. To put it simply, people will not be mapped into the digital world. It will not be in the same reference frame as virtual. Okay. Now, in mixed reality, if I want to set here with a mixed reality headset, all of the objects in this room will be identified and boundaries will be put around them. So if I create a virtual object and put it on the table, these two objects will meet, the real and the digital, in the same Cartesian, let's call it reference frame. Okay. So this is what mixed reality is. Extended reality covers everything. So what we do is gloves for extended reality, and we plan to implement it in many applications spanning all VR, MR, and AR. Okay. So this is the glove we have until now. In this case, I cannot say everything about the methods that we are using because they are not patented yet, so on, but I will tell you the basics. We now have a glove. It has fingertip detection. So when you try to rub a surface, for example, you feel some vibration which represents the roughness of the surface. Okay. Right now, the level of actuation development allows us to create acceptable realism for relatively rough objects, like rough wood and so on. But a lot of effects can give you tactile information and make things more realistic for different kind of surfaces as well. When you interact with an engine, for example, you can touch it and feel the engine roar. And trying to find out if there's a fault. When you press a button, you do feel that you press a button, and this gives a deeper cognitive connection and more sustained learning of a task and so on. And it's also very natural to do that. Okay. Also, our glass are optimized for infrared reflectivity, and we use machine learning counter for this problem of not being able to create a feeling of very fine surfaces yet. And we have also created an SDK. The developers can get this SDK, install it, and then they can simply drag and drop objects in their environment, and that's it. They are compatible with our cloud. Okay. This is one of the most, maybe it's even more important than the hardware. So this is a video which shows a bit how the lab works. Don't like this music. Like so you can start with touch the object, basically fit your arm. So here we compare different references, the test environment company. And basically here you see that somebody can simply, you can see the button here, you can drop it in your environment, change shape, color, and it's already compatible with the glove as a haptic. So both products are due to launch now. Just to let you know, the extent of the reality market right now is at in 2023 was at $142 billion, and this will be 7 times this in 10 years. So this is a nice market working to get a job in, to do stuff relevant to this market and so on. Now it's kind of connected to machine learning as well, AI, even agentic AI. So this is a good area to learn. And this is the timeline of my company. In 2007, I founded the company because I had this idea, as I told you, for deaf people. Nobody was thinking it's possible to do that. So I managed to get a government funding of 50,000 euros. With this money, I covered the research that I did at university. I paid it from my company. That's why the IP belongs to the company. Basically, I subcontracted my university to do this job. I gave the funding to the university. Let's say like this. And now 2020, it was COVID. Hey, I want to make this a bit personal, guys, because here on this presentation, I want you to remember this. I want to inspire you to make stuff. Okay. If you do research and become academics, do spin-offs. Solve the real world problems. Okay. So in 2018, I came from Kazakhstan to Cyprus for family reasons. I was shortlisted for at least 5 positions. I had early possibility. And I came here and I was not hired anywhere. So I'm also a rock climbing instructor. So I was teaching rock climbing, doing some consulting, and keep trying to get funding from my company. In 2020, there was the first lockdown. Okay. I had already applied 2 times for seed and pre-seed funding. In the first evaluation, I got 14 out of 50, very high. Like mark, but I was rejected in the second phase on the business part. I didn't lose my day. I keep trying. There's a lockdown. I broke my right hand. I was training on the stair, running up and down, then relax, drop down. And I went to the general hospital. It was like dystonia. Everybody was dressed like astronauts. They were like, it was crazy. And so my family said, come on, man, get a rest, relax. But there was another deadline for standing. I sat down and I wrote it with the left hand, like this. And I got this. $500,000 public funding to do us. So then we kept developing the product. We got 300,000 of investment from Genesis Ventures. I was one of the first companies in Cyprus to get private investment. And we kept evolving. 2025 is the year of commercialization. This is a nice story. It doesn't mean we will succeed. But we gave it all and I'm content. What we are going through now is called the death valley. This is where most companies don't make it to the market. Okay, but we are trying and we feel positive. We think we're going to make it and become a scale up. So we already have discussing agreements in the UK, partnerships for clinical testing. We are now launching the pre-order campaign for assets. And just today we became partners with HTC Vive. So this means we get access to all of their ecosystem, technical support. We're going to make our device compatible to their headset, and we will have a lot of collaboration with them. We also made a collaboration with a British firm. We are developing a robotic sensor system for them based on our Haptics solution. So things are going, but a lot of effort is needed as well. This more or less, I think. Okay, just some stuff now regarding research versus academia. In research, okay, in the academia, you have a subject, you investigate a subject. I'm not saying it's easy, I'm not saying it's not significant, but when you make a startup, things get tough. This is the hardest thing I did in my life. It's harder than the PhD average I did. Okay. It requires multi-level work and thinking, R&D, talents, business development, marketing, compliance. You need to get CE. You need to test your products. You need design. You need to make them desirable. You need to test them with users. You need to know that the users want them. It's crazy. And it's like my brain is divided into many different compartments that they all work at 100% at the same time. I've never experienced this thing. And even the management is very hard. You need to go through many stages, do iterations. You need to get people to love what they do. It's impossible to make a startup succeed if your team doesn't give their whole effort to achieve what you have to achieve your goals. Okay. So finally, why not make a startup? This is me in 2018. I was climbing Zernina. I was doing alpine climbing out there. This year it was like 4,000 meters. It was very hard for me. It's dangerous. I lost good friends in the mountains, unfortunately. And I don't know why this looked like this. Anyway, it's the conversion. But anyway, I found many parallels between climbing mountains and entrepreneurship. Okay. And this helped me navigate better in my entrepreneurial journey. All right. And some of these things are, if you do a startup, you will have a lot of uncertainty. We will have money next month. We will have money next year. Okay. I mean, it's you do testing, EMC, electromagnetic compatibility will go through. If it doesn't go through, what will happen? I need to spend 50 more thousand to make it go through. Limited second chances, adaptability, you have to change. Every day is different. I'm telling you, every day is a new day. Every day I have different challenges than the previous day. Nothing I do each day is something like every day I will have to do something for which I have no prior knowledge on how to do it. You don't understand how tough is it, how wonderful as a life experience. Okay. Also, physical and mental endurance. That's a must. Okay. You must go through continuous effort, failures, rejections, and keep your cool, keep going. It's something that if you don't have, you build it. If you don't have it, you will build it, or else you will go. Okay. Dealing with fear, there's fear, a lot of time. If things are going okay, am I going to investment? Am I going to run out of money? Go bankrupt? Oh my God, then everybody will hear that I went bankrupt, and then have you managed to handle all these feelings, focus on the job and that. And balancing ego. Okay. You need to have some pride. Investors will not give you money if you are too humble. But you need to be humble, or else you're going nowhere. Anyway, so make a startup. You will solve real world problems. You will do something that has impact on people now. You will lead a life which is creative day by day. Okay, university is good. They do fundamental research. Corporations are good. They scale up the solutions and make them mainstream. But I think making startup is absolutely amazing thing to do in your life. At least one. So thank you very much.
So I'm blown away. It was a very interesting talk, but lots of interesting things. And before I hear off with my questions, does any of you guys have questions for Evagoras? Yes, go ahead.
Which was hardest being the product development?
Hardest product development stage was the algorithm, the signal processing algorithm for us. You need to identify phonies. You need to do noise cancelling, and you know it's different than noise cancelling. Yes, because there, what you listen is different than the noise you are canceling. Here, this device picks up the sound, and in that sound is the sound you want and the noise you want to reject. Okay. Already we have a good noise cancelling algorithm. It's not super, and our first device will be recommended for relatively quiet space. Also, we need to identify speed of the music and so on. I think that part was the harder part in development. Also, the electronics. I'm happy I had great collaborators that helped me.
Other questions?
About the different modes.
Yes.
And we manage the algorithm like sensitivity, how do you differentiate the different CPU stage?
Okay, if you take cars, for example, we can even identify electric cars because it's from the tires. If you go in Shanghai, Illinois, the tires. There are certain frequency signatures of each sound. Like, for example, the cars, there is quite some literature that gives you the signature. That's where you are in deep. It will solve hard engineering problems with solutions that span development and research continuously. So I think there's some range and some spatial some frequency signature for detecting sounds in phonemes. Try to say this, which let's do it. But speak now, you only once, guys, don't be shy. You only change the position of your lip. You say yeah, yeah. You only change the position of your tongue. So when we speak, each phoneme has 3 formal frequencies. These are the frequencies by the voice box, by the tongue, and by the lips. And this frequency, these are 3 resonant frequencies. They are pretty average for most people. So when somebody speaks to you, you try to look for frequencies in those ranges, and you try to understand, okay, this is the phoneme A, for example. You can also split between high pitch and low pitch. Anyway, it goes on and on and on. Yeah. Okay, gave you an answer.
More questions from us, from the audience? So I have a few questions.
Yes.
Obviously, the products and the nature of the company is multi-interdisciplinary. You have electronics, mechanical engineering, software, signal processing, all that stuff. How important is for a startup, for a company that makes something new, to use that interdisciplinarity? Is it something that is absolute must in the era we live with machine learning and AI?
There is no other option.
There is no other option.
The haptics combine neuroscience, biomedical engineering. About what's relevant to the brain, the central nervous system, relating to electronics. Okay, you asked about the challenges. I talked about latency. Latency was hard to achieve in the haptic lab and in asset, like having low latency between touching virtual objects and what you feel, or what you see and what you feel in the case of us. So you need signal processing, you need product design, you need manufacturing knowledge. And as you keep going and going, you start having bigger challenges. You need to design your device to be able to be manufactured. Okay, now we are going like 500 devices, but if we scale, if we go to make 5,000 devices, you must make sure from before that your device is able to go to that level without doing a whole new design for 2 more years. So it even needs production, industrial design knowledge. In development, you need to know how to create commercial software, not just software. Happily, we have a very good developer, IREROBOT, which helps us develop commercial level software. It's not the same as developing a software in your research. There are many different. Also, the management is different in each area. Different to manage R&D, different to manage product development, different to manage software development. You have different. So, what's my answer? Sorry, now you understand this thing with the compartments in my brain.
Yes.
But the most important thing here in multidisciplinary areas like this is to trust people, not to micromanage. Different to micromanagement. I don't want to say.
Speaking of that, the interesting thing is, how do you find and hire the right people? That's a very challenging thing. I
It's
believe.
challenging. I had my first crash. But it's very hard to find a good balance between abilities and character. Okay. You need people who have passion, who are team players, and who positive. Okay. You cannot go all through these challenges. People who are negative around. Okay. You know, there are a lot of this happening. a lot of problems, a lot of mistakes all the time. You cannot be negative. So this is very hard. Now we have a great team. We have great people in the past as well. But I think getting the right people in the company is one single most important factor of success.
We're running out of time, but I have a couple of more questions.
Okay.
The first one, you mentioned all these problems and challenges as you were going through. What kept you motivated? What was the thing that gave you the energy to say, you know what, I will overcome this challenge again. I will try harder and harder. What kept you not saying, well, okay, I'll stop here. It's enough. I had enough. I'll just find a new job.
I can't say there's something. But judging from previous experiences, I think I have this in a way. There were times where I quit under different circumstances, but there were very few cases where I didn't like what I was doing. So I think that I find it, I want to make this work in a way subconsciously. I think it will go existential. Okay, we live, then I don't know. You need to do something with meaning. I think this is something with meaning. I want to make it work. So I will give it all.
And finally, what was the biggest lesson you've learned throughout this journey? And how can we share it with everyone here? Share this knowledge.
I wish I knew how to do this earlier. I didn't know how to do it. If I knew how to do it, I would do it earlier.
Okay, so the lesson is to do it as early as
The
possible.
lesson is that your environment will not necessarily give you your calling. Search, find, interact with people, go abroad, go to conferences, try to find this calling of yours, what you want to do in your life, okay, which will give you fulfillment. You might not be able to find it here. You might not have the knowledge or the people to show it. This is my best one.
All right. Thank you very much. Okay.